And welcome to, good morning, welcome to Calculus in the AM. I'm your host, Mr. Sundelica. Okay, area under the curve is what we're looking at. The fundamental theorem of calculus. There's a number of ways this can be stated, but suppose f of x is a continuous function defined on this closed interval from a to b, so a number like 2 to 7, numbers. And the function is greater than or equal to 0 for all points on the interval, meaning it's above the x-axis. So this statement here means the function is bigger than 0, right? It's above the x-axis. Then the area bound by the x-axis and the vertical lines, you know, like 2 and 7, a and b, and the function equals f of x, so x squared plus 5 minus 2x, or whatever, is given by the integral, the definite integral, okay? So you are finding areas trapped. So this area. Now, this picture shows something that you probably didn't do in physics. If you did, you were approximating, right? You typically, when you did integrals, not calling them integrals, to find displacement, etc., you were using triangular sections, rectangular sections, etc., right? Here we can use curves, because if you have a function to approximate. Okay. Example: find the area bound by this curve x squared plus x, the x-axis and the lines 1 and 5. So I have the drawing set up here. Here's the parabola, and we're finding this area. Of what value is this? None, unless you attach it to a word problem. We're not going to get so much into the word problems, but just telling you where you're possibly going to see this. In physics, since there's more people doing science, physics is most likely where you'd find it. Don't worry if you're just a regular science major and you're taking physics 109 and 19 in university. You won't call it integrals, you won't call it derivatives. You won't do calculus. The formulas are all worked out. So. But if you're doing regular engineering or a physics major, you will be looking at, or chem majors sometimes. So how do we find the area between 1 and 5? What's the operation? The definite integral, right? So I'm going to say the area, and if you use a with me, I'm fine with that. I know it's area. A is equal to, well, the lower limit, 1, upper limit, 5, the function, x squared plus x. So you got to set that up. I'm missing one little thing, and it's like one of those nitpicky things. No, I haven't solved it yet, and there won't be a plus c. This will be a definite integral, dx. Okay? So just pointing out another nitpicky thing. Common thing is that people forget the brackets. If it's a polynomial with more than one term, you need a bracket. Often, if it was just x squared, you don't need a bracket because that just applies to dx. Okay? If you don't have the bracket, it looks like the dx is only attached to the x. Like I said, nitpicky little thing. Now the plus c is of no consequence here because you could put it in there, but it subtracts out. What is the antiderivative here, this solution? What did I have that possibly gave me x squared plus x as my answer? Plus an x squared, and because if I do the derivative of x squared, I get 2x. I don't need a number in front. Yeah. Okay, you guys are becoming cracker jacks, I guess I can tell. And now it's just arithmetic from here, right? Now, I'll do the arithmetic with you, just to show you, and I showed you this technique the other day. Be prepared to do this kind of stuff without a calculator. You can have a calculator in my classroom, but I'm thinking ahead. So, x cubed with 5 plugged in it, 5, 25 times 5, 125. Out of 3, plus 1/2 x squared, so 25 out of 2. Subtract, well, 1 is way easier to use. 1 cubed and 1 squared is 1 squared. I put the bracket there just so I don't forget, and that's the most common arithmetic error, is forgetting to distribute the subtraction if you have a number of things. Now, 2 methods of solving. What was the method I showed you when you have fractions with different denominators? Yeah, match the like terms. It often saves you time. It doesn't always. The other way is to do the brackets first and get a common denominator. And you might end up having to do that, but sometimes you save yourself a heck of a lot of work. So, let's see what we get here. 125 minus 1 is 124. 25 halves minus 1 is 24 halves. Okay, so I'm, instead of doing the arithmetic out of 6 here, out of 6 here, and combining, I'm saying, well, let's simplify things. Sometimes it does, sometimes it doesn't. If I just take this and I distribute the negative sign here, so subtracting the third, subtracting the half, making sure that I don't do something wrong. Now, is it any good, what I just did? Think this through. I could tell 124 doesn't get me further. It's not really that great. This one here is easy to think of. Well, this is really 12, right? So I'm thinking in my head, 12 as a fraction out of 3 is, tra-la-la, 36. Okay. So I think of it still as easier as probably, so 120, yeah, whatever I'll use, but 124 out of 3 plus 36 out of 3. 160, yeah. Out of 3. If you want a mixed number, go for it. I don't really care. Okay. But you know you can manipulate that number and so on. Now, what did we find? We found the area under the graph. Depending on your problem, that could solve some scenario. The distance traveled from time 1 to time 5, for example, if that was a velocity time. Applications you'll get later on. Now, pardon me, find the area bound by this curve, 1 over x plus 1. Now, before you do too much, look at your function. Polynomials don't have restrictions. Square roots have restrictions, even roots have restrictions. Odd roots don't. This has a restriction. What is this function's restriction? Yeah. Non-permissible value, whatever you want to say. Why? Because when I graph it, what does this look like? Well, -1, I can't have any values. So what would you put there? Just as a rough sketch here. What would the negative? An asymptote, a dotted line typically represents that. And what does the shape look like if somebody could do some hand slices or Tai Chi kind of thing the way you're doing it? David Bowie on the Heroes album cover has this kind of done. Anyways, the reason why I do that is, keep this in mind. I'm doing the area from 1/3 to 3, so I'm safe here. That is the area, now I didn't draw this very carefully, but it's the area that's the skinny area right here, right? The way I drew it, it's pretty skinny. However, if I had done I asked you to find the area from -2 to 0, would that have made sense? Like, just take a look. Oh, no, because you got this aspect broken there. You have to have a continuous function, okay? So that's That's something to keep in mind. So we want the area A from lower bound 1/3 to +3. They're both positive, so this is good. 1/x+1 dx. I don't need a bracket on this because the fraction implies that it's an implied bracket around the denominator.
How do you know which ones we're talking about?
Lower to upper, higher number on the top, if you're doing an area. Is that what you mean? Like 1/3 to 1/3?
1/3.
Yeah, 1/3's the smaller number. So left to right, as in 1/3 to +3. Lower bound, lower number. Upper bound, upper number, higher number. Okay. If you do it the other way around, you get the same answer but the opposite sign. And you'll have a negative area, which in this context doesn't make sense. There is some contexts, if you think of physics and stuff, where a negative area as well, a negative position or a negative displacement, I mean, would just mean you're going the opposite direction. Now look at this. Can I solve this one? Not easily? Yeah, okay. Natural log, maybe. Well, you guys, yeah, it looks like it could be something to do with the natural log. If you can't figure this out the way it is, let's solve it using substitution. What's the problem here? The x plus 1. Yeah, let's go with u equals x plus 1. So we'll let u. By the way, you could solve this in one step, but with more practice maybe. So du is equal to dx, and that's great. Because, okay, I've got the u for the x plus 1 taken care of. Then all I have left over is the dx. I have no x's left over. Now, when x equals 1/3, when x equals 3, u equals, oh gosh. So that's your next step. One-third, what does that turn into for u values? 4/3. And then the 3 plus 1 is 4. Good. I set up my new integral, it'll be easier. So the area equals, now I've changed from x values to u values. I put the 4 in the wrong part. Okay, there, 4/3. And the new function is 1/u, or u to the -1 if you wish, du. The substitution took care of everything. And it is the natural log as suggested. And so all we're excited is just because it looks like the kind of space I have. The natural log, I'll put the absolute value on there. But we could see that it's all positive stuff we're putting in here. Nothing but positivity in this classroom. Now, no calculator, no problem. I'll just leave this as natural log of 4 minus the natural log of 4/3. Okay, which part? Here, backward substitute. If we are doing definite integrals with substitution and we've changed from x equals to u equals, we're fine to just plug in. In a sense, didn't we take care of the x plus 1 when we added 1/3 plus 1? When we added 3 plus 1 to get 4 here? So it's all, as long as you do that u equals step for your two values, you're just getting a number. So you shouldn't have x's in your final answer. You with me, kind of? Yeah. Definite integrals, you don't have to backward substitute, if you want to say that, if you've done this step correctly. Yes?
Can't you just go forward now before 3 and then, like...
I was gonna say, can we simplify this a little bit? No, you've really got the answer, and if you had a calculator, you could type it in and get a decimal. I don't really care what the decimal is, though. Okay. You're saying natural log of 4, subtracting natural log of 4/3. I know it's a log, so they're actually answers to exponents, right? So the laws of exponents apply to logs. And when you subtract exponents, you're dividing. So, you suggested correctly that we've got 4 divided by 4/3, right? When you divide by 4/3, flip, I say your fingers, yeah, reciprocal, multiply by the reciprocal, flip and multiply. Which is 4/10 of the natural log of 3. And there, if you really want a decimal value, like an approximation of that area, that's an exact answer, just like √3/2 is an exact answer for other problems. Leave it there. If you want to use a calculator, if you need to, if you're in a physics problem, you'd need a decimal answer because it will represent some kind of distance. Okay. Now, take a look at this one here. I'll give you guys a moment to do this. Set it up. It's similar to the other one, but just think back. Have you ever had one of those tests where it says read all the instructions on the page before doing any questions, right? And I know what happens, grade 5 students, they start doing it and one of them is like clap your hands twice, hoot, hoot, and stuff like this, and everybody's doing this. And there's one little girl or something that's sitting in the back and she handed hers in after 30 seconds because it says read all instructions at the very end of the last page. 3 pages later it says, now that you've read all of this, put a star on the upper right corner, sign your name and hand it to your teacher, right? Now, why do I bring that up here? What's the first thing you should have done? And I don't think you did. What's the non-permissible value for this? X can equal 2. That means if I graph this, what did it look like? At 2, we've got, okay. And what are we finding the area from? 1 to 4. Is this a continuous function?
No.
So,
Oh my God.
you now see why I was bringing up the old read all instructions. Well, take a look at your general shape before you try doing this. You can't find this area. So, no answer. It's undefined.
Yeah, that's why when you do, you get like a natural log of -2. And that's like the opposite.
Well, you'll get an answer, like if you do the integral thing.
Yeah.
You will, but it's wrong.
Yeah.
You can only do it on continuous portions. I thought I'd only give you a few.